Hello everyone. Welcome to the third of three webinars dedicated to destination of data lake. Today we're going to talk about the ISLET, the infrastructure part of the destination of data lake, which is about also deploying your own virtual environments, about deploying your Kubernetes cluster virtual machines, Python environments, and in fact whatever which is dedicated with with some kind of virtual environment. Yeah, I'm going to I will present it together with my colleague Michał. I'm going to tell you something about ISLET, let's say from more theoretical side. While Michael will introduce you some exercises and how to deploy virtual machine. I hope, because in the meanwhile we had some technical issues, so I hope it's going to be resolved in the meanwhile. But let's start with this theoretical part here about ISLET, about infrastructure and using cloud resources of destination or data lake. Okay, what's going to be covered? Firstly, quick overview of the previous two webinars dedicated to data discovery, data access, and to two of edge services, Stack and Hook. Then I will introduce you ISLET from more, as I said, theoretical point of view. Then I will show you how to request for access to ISLET, something similar, which was held also 2 weeks ago, which was dedicated to Stack and Hook. Then some exercises here, as I said, demonstration how to create virtual machine via Horizon dashboard. Also access this virtual machine through X2Go's software, which is a dedicated version of this X2Go software to DDL, in order to use it, let's say, in more interactive way, just like your own local station, in fact. Then, in the meanwhile, also we're going to create an object storage bucket. This part is connected with creating a virtual machine. So, in fact, this part is going to be
interrupting you. We have an issue with the screen sharing. So right now we see a black screen on your side as well. So could you please maybe restart the screen sharing?
Yeah. How about now?
Yeah, now we see it. Thank you.
Thank you. So then we're going, at the very end, we're going through some kind of summary and Q&A session, of course, if you have any question. Okay, so let's start with the overview of the first two webinars. Quick introduction, quick reminder about Destination Earth, flagship initiative of the European Commission, which aims to develop a digital replica of the Earth, in fact, manual replicas of the Earth. In this very moment, there are provided two of them. One which is dedicated to the weather, to the extreme events, so-called extremity, and one which is dedicated to climate adaptation and climate scenarios, so-called climate DT. Destination Earth includes three main components, which are core service platform, which is let's say entry point to the users. This is the place where you have to create your account to interact with DESP as well as with DDL services. Yeah, so you have to be DESP registered user to use deadly sources. Of course, there's data lake, yeah, which allows you to discover, access data in many ways. For example, using HDA, which was introduced in the first webinar. Also, it provides big data processing tools, infrastructure, as it's going to be introduced in this webinar. And finally, digital twins and digital twin engine, which is about providing data of produced by digital twins. Okay, this is important. I already talked about this on some of the previous webinar. However, especially in terms of today's meeting about ISLET, it's crucial to remind about it. So, what is significant for that is distributed infrastructure. 5 cloud sites, so-called data bridges around the Europe. Yeah. So we have three clouds, 3 data bridges, which are located just next to the HPCs, which are Lumi, Leonardo, and Mare Nostrum, as follows: Kajani, Bologna, and Barcelona. Also, we have two others sites, which are UMETSAT Data Center and Cloud4 Data Center in Warsaw, so-called central site. Why clouds are located on such places? So it's because data produced by digital twins are produced on HPCs. Yeah. So let's say if you're interested in interacting with digital twin data, digital twin outputs, it is the best way to do that is to deploy your virtual environment on cloud which are located just next to the centers where the data is generated. Yes, in order to reduce some kind of latency, to avoid this latency. Yeah, because this data is huge. It's there are terabytes of data. So this is why to provide the users processing which is possible just next to the data. So that's why 3 of these data bridges are located just next to the HPCs. On the other hand, let's say if you want to do more with UMETSAT data, Meteosat, or maybe some data which are produced by SAS, the best way is to deploy your cloud, you create your virtual environment on UMETSAT bridge, because it is located just next to the place where the UMETSAT data is stored. Okay, and finally, if you're most interested in Sentinel data, the best way is to create your virtual environment on central site, because this cloud on the edge, this data bridge, is located just next to the Copernicus data center. Okay, so this is about infrastructure. Important thing, it was done in order to reduce latency, to avoid this latency, to provide possibility of processing, dealing with the data just next to the data. Okay. Again, about some kind of reminder. Firstly, 4 weeks ago, we learned about HDA, which is about data access and data discovery. HDA, which provides an access to about 200 collections with 1 credentials and 1 API based on Stack. So let's say this is the base, yeah. But 2 weeks ago, we also identified so-called edge services, which are available on request. Of course, still on charge, but free of charge. But you have to request for this service. But it's not kind of proposal. It's more like short justification. Why do you need such resources? What are these services? So Stack and Hook, which were introduced 2 weeks ago. Stack, which is mostly about Jupyter Hub and possibility of parallel computation, about distributing your jobs on different location, on different pods. Hook, which is mostly about, which is some kind of function as a service, which allows you to create your own workflows, or to call some ready to use processors like backscattering, coherence, or atmospheric correction. So you don't have to code a lot of stuff. You can use something which is ready to use. And today I'm going to talk about ISLET, about especially about ISLET compute, but the part of that is also ISLET storage, ISLET compute, which is about let's say more like virtual machines, while ISLET storage is more about storage. Yeah. Okay. In fact, I've already reminded you about harmonized data access. The most important thing was this one credentials, one API, around 2,000 collections, of course, including digital twin data. Very, very convenient tool. Yeah. Stack. It's about Jupyter Lab and about creating dust clusters on different location. It's possible to create them on different location, again, in respect of what kind of data are going to use in your analysis. And finally, Hook, which is about this function as a service stuff, about providing predefined processors. Okay, so now time to introduce you a little bit more about ISLET. This slide, I guess you are familiar with that if you if you joined our two previous session. ISLET, in fact, is divided into two parts: ISLET compute and ISLET storage. ISLET compute, which is about, as I said, creating your own virtual environments. It is based on OpenStack, so open source project. ISLET provides both CPUs and GPUs. So if you really need the GPU, if you're going to clarify, if you're going to justify it in the proper way, you can be granted within access to GPU as well, not only CPU. Yeah, ISLET storage is about storage, about accessing and managing S3 storage. So what else? ISLET provides you an access to these virtual environments, as I said, but it also provides you ready-to-use images, which are based on some kind of Linux in the distribution, different Linux distribution, including Alma, Debian, OpenSUSE, Ubuntu. Also image which is based on OSGeo Live is provided within DestinE Data Lake. Also some images which are dedicated to work with Kubernetes clusters. So this is something which is called images. On the other hand, we have something which is called flavors, which is in fact about resources. Yeah, flavor defines how many RAM you can use, how much RAM, to your total disk space, also how many CPUs or GPUs you can use in your virtual machine. But the question is, why do you need this, in fact? Why do you need ISLET? Why ISLET is such an important part of the DestinE Data Lake? I mentioned a few slides ago that data provided by digital twins, and in fact Earth observation data, is provided in huge data sets. Yeah, so their volume is like hundreds of gigabytes or even terabytes, few terabytes. If you're going to perform some climate analysis in terms of 20, 30 years for many variables, it's even going to be like tens of terabytes. Yes, so you need an infrastructure, in fact, in this way. So this is it. DestinE Earth and DestinE Data Lake. It's not only providing data, which is great, which is something new in, let's say, Earth observation environment. Yeah, but it is provided with infrastructure, so you don't have to worry about I don't know if your laptop, your local station, your hardware, which is provided by your institution, is enough, because you can always access for more. You can access for some resources, virtual machines, access to virtual machines on DDL. This is the example of such a process, which requires a lot of RAM, a lot of disk space, which is about creating data cubes. Yeah. Let's say this example, which I introduced to you at the very beginning of the slide. Let's imagine you want to analyze, I don't know, tens of variables of maybe, let's say, 20 variables which are provided by climate DT. Yeah, this data is provided in with 1 hour time resolution for many years ahead. So it's going to be like terabytes of data. Yeah. So in order to firstly download this data, store this data, process this data, maybe to ZAR, maybe to NetCDF, maybe also combine it with some, I don't know, UMETSAT, Sentinel data, whatever. It requires a lot of RAM, a lot of CPUs or even GPUs. So that's why I'm here with ISLET, yeah, because ISLET provide you necessary infrastructure. And here we have some examples of using Xcube in terms of data cubes, so you can also expose your results of your analysis in some fancy way, graphical way to the users. Okay, so I stop sharing for the moment, because now I'm going to show you how to access for an ISLET. In fact, it's going to be just the same like you access for Hook and Stack. Maybe first a quick reminder, yeah? So you have to be registered user of Destination Earth Core Service Platform. Then you can navigate through DESP, or you can navigate directly to Data Destination Earth EU, which is a Destination Earth Data Lake portal. And then you can find My Services tab. You will be redirected to the service, and there you can, you can fill out form, you can write a request for any services, of course, including ISLET. Okay, so I will stop sharing for the second. I will show you how to raise a request. For that. Give me a second. Okay, now you should see my screen. I hope you can. I hope you can see the web browser. Okay. Okay. So firstly, you have to log in, authenticate using your desk credentials, as I said. Then you will be redirected to to that portal again. And here the tab which was introduced to you 2 weeks ago and also 4 weeks ago, My Data Lake Services. So you have to fill your profile, of course, but in order to raise a request, you have to go to Project, then navigate to Add Project, and here fill out the form. I will fill it with some random information. Of course, it is evaluated later, so it's not like that you can write here anything, yeah, because then this form, this request is evaluated by human being, not by AI or some kind of system. So in fact, this data has to be valid. But what I want to show you is what kind of how it look like when you have to choose flavor or quota and service which you want to access for. Here I will choose that. Next, and here it is. Yeah. So if you need ISLET, you have to click on ISLET. You can request for three specific, in fact, for four levels, which is dedicated to quota. This is described by quota. So ISLET low, ISLET medium, ISLET high. It's about resources. Yeah. So low is the lowest one. Medium, high. Of course, high provides you a lot of resources, the most of resources. You can also click here, custom, and define what are your needs. And then if you choose something, you can click next, next, and finally you will go to justification form. Maybe we'll go through that next. Yeah, it's important. You are requesting not as a user, as a single user, but as an organization. So if you're going to request as an organization and you choose, let's say, number three as a maximum number of users which are going to use it, three users, three persons from your organization can access ISLET service. Next, and here, as I said, this is the form where you have to justify why do you need this service. If you write something, not something, it has to be at least 500 characters. You can submit your request. Okay, so that's it from my side for now. Michał, could you try to share your screen and talk about deploying virtual machines?
Yes, thank you for your patience and sorry for this technical
No
issues.
worries.
I have disabled Wayland, so it should work now. So restart the PC. So let me test. It shouldn't be this screen.
Yeah, it's working.
Okay, perfect. So yes, okay. Let me start from launching a virtual machine. Our first activity will be launching a new virtual machine, which is basically a core of cloud computing. So let's go to the instances. I am logged here as a webinar user with basic roles. So here we need to launch instance. Instance source is a template used to create an instance. So we can use an image, a snapshot of an instance, a volume or a volume snapshot. You can also choose to use a persistent storage by creating a new volume. In our case, we will simply select existing and pre-configured images. To save some time, I have prepared. I will try to paste here. Sorry, not here, but later. Let's name it this instance webinar virtual machine. And of course here, let me select this one. This is Ubuntu 22.04. And the flavor. It defines the size of a virtual machine that will be launched. So how many virtual cores, RAM memory, and disk storage it will take. Let's select. Now the networks I have already prepared because while we are creating the users for the project, we will have the network also pre-configured with it will be external network. So let's run this one here. Now, security groups are very important because by default we have egress rules, so we have to add also ingress. We will have possibility to ping SSH machine now from the key-pair, because I have prepared my SSH key. So let me select this one. And this is the last step we have to complete before we launch this new instance. You can see this creating now building. Okay, and this is active now. So we have created the instance without errors. Let's go to the next step. So I will try to connect with this machine using SSH connection, uses this webinar key pairs. But in order to do this, we need to attach the floating IP address. And in order to do this, you can simply click here. Create a new floating IP address. We can describe, but we don't have to. And allocate to this particular instance. See it. This floating IP address is an address from a public pool, and it can be accessed over internet. Let me now open the terminal. Please confirm that you can see my terminal on the sharing screen.
We can see
Okay,
it.
thank you. And let me try. So I don't see my new floating IP. I can also, of course, copy paste. Maybe I can show you. It will be fastest. I am using EU username because it is the name written in the images. It should work already. Yes. And I am now connected to the webinar virtual machine. What else we can do now? We can of course check. Before we perform connection via SSH protocol. We can ping this machine. Ping the. Let me show you. In order to check if this is reachable from the internet, because I'm connecting now from my local. So let's use the floating IP. And for example, if I want to check if the 22 port is open, and now I can see that we have successfully connected this virtual machine to the floating IP and to the internet. Okay. Let me close this. I will leave this connection open. I will use this later. Sorry for a moment, I need to drink something. Okay, but let's at this point assume that we will need additional virtual machine with a dedicated network, for example, with a private network. First, I will start from creating new network. In order to do this, let's go to the Networks tab and create network. Let's say it will be it can be webinar private network as a name. It has to be checked. Now we need to define the subnet. Subnet name could be example webinar subnet private. Yes, we leave here and our network address manually. And gateway IP. It's normally the first available address in our subnet. So this is 3.1 here, and in subnet details we should provide allocation pools. And that's it. Let's create this network. Okay, we have our network here. Let's create new instance. I prefer to use now the image with the GPU. Let me find this one. Can be, for example, this one. Flavor, as before. All those steps are the same like before. We can use, for example, we can try because sometimes we can meet our quota limits and select network we have created before, our private network. Let's add our security groups, so we will be able to connect if we need to allocate floating IP address and ping this machine or connect SSH. K-pairs, my good know webinar key. And that's it. Let's try to launch this instance. Okay. In order to test connection between these two, those two virtual machines, let's try ping this machine from our previous. So from here, from webinar virtual machine which I created before. First, of course, we need to allocate floating IP. Yes, we don't have ports here, but what I want to show you is that we also cannot ping this machine in this moment. We will see that the destination host is not reachable. 100% loss. So let's go to the network topology. Maybe we will see what is wrong with this. This is our recently created webinar private network with GPU virtual machine, which is not connected. We can see here by the colors, line with the color, this is external, and we have the routers here. This is our router, which is connected to the first virtual machine, and it has connection to the internet. So what we have to do now is to connect to private network. And to our router. So we need to go to the routers. and try to add interface. Webinar private network. This is optional. You don't have to put any IP address. Submit. Let's go back to the network topology. Now we can see the connection between webinar private network and our router. Also, the webinar ISLET is connected to this router. So let's go to the instances. Let's try to ping from the first virtual machine. And now we have connection between these two virtual machines in this private network. So the first one doesn't has connection to the internet, but we can connect with our webinar virtual machine internally. Okay, so let me minimize this one. I want to show you how to create a new block storage volume, because at some point we may notice that our virtual machine is running out of space. So first we need to go to the volumes. Create volume. Let's take volume. Okay, this. Let's say we need an additional 20 gigabytes, and that's it. Let's create and let's check. Okay. Now we have created a new volume because I will store some files here on this new disk. I need to first connect, assign or attach this new volume to our dedicated virtual machine. Let me attach this one to webinar virtual machine. Okay. Let's check list all our block devices. You can see this additional disk 20 gigabytes here as SDB. But before we can proceed with read and write operations, we have to prepare this volume for operation. I will now create some new partition on this volume. Next, we will format this and mount to this virtual machine. There are several commands, so I will type these commands here in the terminal. Now I am creating the partition table. Here it is N. I need to focus here because we are waiting for one sentence. Okay. Now W. Okay, let's check with the same command. And we can see the partition here. Okay, but now in order to save data on this volume, we need to format this partition. So in order to do this, we will do ext4 file format. Execute. Okay, it seems to be completed successfully. Okay, before we proceed with creating some files here, let's mount this this new volume to the virtual machine as a block storage. So we will mount this permanently. So in the next let's say restart of this virtual machine, we do not have to remount this one more time. First, we need to install text editor. Okay. Because I written here the path to this volume, I should of course create this folder, which will represent the mounting point of this volume. So Now command to mount. Let's check one more time. Sorry. We have to add additional parameters, of course. Defaults 01. Correct. It's the mount when it should work. Yes. To check whether it was successfully mounted, execute, and it seems to be completed without errors because the volume is now owned by root user. So EO user doesn't have access without sudo. To make it accessible to EO user, I will execute following command. Sir. Okay, so we have successfully created a volume and prepared it for use on a Linux virtual machine. We can now copy files to our new volume. If we want to move the data, we can attach this volume to a different machine, for example. Since we have additional free space now at this virtual machine, let's try to create some file and see if it really is stored here saved, and next I will check the size of this file. I will use locate and no, I will use 20 megabytes. So should be. Okay. Yes, I need to change the, sorry for a moment. It's problem with the characters, but I think I can solve this. Okay. And let's take disk space usage. We can see that is available now 19 from 20 gigabytes. So we successfully allocated the file, saved the file into the volume. Okay, so I shown a scenario based on block storage. Now let's focus on object storage. I will show common operations related to object storage. Operations covered by this test case will be performed from the horizon. I will still stay in this terminal. Go to the object storage and containers. Firstly, I will create new object storage. This is the container, so don't be surprised if I will use container or bucket. This is the same. And this is our naming. So let's create the container. One thing, we should use only small letters, small characters, small letters without space. And it should be original name, so it cannot be repeated in the same project. I hope there is nothing more about the webinar bucket. Now we have to choose. If we choose public, we will create the link, and we will use this link for external users over the internet, and they will be able to access our sources in this container. But let me show you now not public scenario. We have webinar bucket. Okay, let me can upload the file here. And this is the place where you can store the files, and it is visible in our horizon. You can of course download the same file to our downloads folder. Now let me show you about the public access. Okay, so it was only the message that we have created in the link, and using this link, for example, by copying this, we have access from our local machine to this bucket. You can see the file which is here on our bucket. But what we can do else, we can download to our virtual machine this file, for example, by curl. we can see that the file has been downloaded, and I can confirm that the what is in this file, it is what it should be. So I can confirm that it was downloaded completely. So we can also mount this object storage to the virtual machine. Of course, also to the local machine, but in this case, I prefer to mount this bucket to the virtual machine. But in order to do this, I need some files in order to authenticate our virtual machine to our project. I need the RC file. Now I'm no, sorry, I need to switch to my second monitor because I have the file here already prepared. Save our time and using command scp, and I have the file here. Support. Okay.
Michał, if you're working on terminal, we can see it right now. We can see dashboard, horizon.
Okay.
Now it's okay.
Yes, because I should have now second terminal. Sorry. Okay, sorry, I have technical issues, but I think I'm able to fix this. Okay.
Michał, maybe in the meanwhile I can show how to access virtual machine through X2Go, and then you can prepare what is required on your side, because it about this X2Go it's going to be like 2-3 minutes. So maybe we can keep here.
Okay, sure.
Okay. Okay, so I will share the screen. Mm, mhm. Give me a second. Okay, I guess that now you can see the the desktop application called X2Go. This is the version which was let's say arranged to dedicated to destination or data lake. How it works? What is it? This X2Go. So it allows you to connect with your virtual machine with graphical user interface. So when you log to your virtual machine, when you connect with virtual machine in such a way, you can use it. In fact, just like you can see desktop, you can see folders. In fact, this looks like the same as it was run on your local laptop, local computer. Okay, so how to connect? Here you have to click new session. I already prepared something which is ready. I called my session DDL X2Go. Here in the host, you have to paste your floating IP. Michał already mentioned about it, that is required if you want to expose your VM to the world. Yeah. So you need this floating IP. Login always is EO user, and here you have to provide path to the file where your access key or private key is stored. Also here you have to check try out login, and here choose the XFCE in order to connect. Okay, and now when it's configured, you can click OK. It was about preparation, yeah. And now in order to connect, you can click on this symbol of the globe. Now I found some technical issues. About my key. I tried just before the presentation, and it was fine. Maybe I will try one more time. Okay, so I will try again with DDL X2Go. And the path was right. It was okay. There's X2Go. Oh, okay. I terminated. Now I believe it's going to work. Yeah, and here is it. X2Go connected with virtual machine. As I said, it looks like it's just your, let's say, local machine. Yeah, you can find some folders over here. If you go to terminal, you can verify, let's say, Honda version. because these virtual machines, these images are already provided with some basic geospatial Earth observation remote sensing tools, which are installed within Conda, within Python, of course, here. There are two environments which are ready to use. One of them is DDL. And when I choose this environment, yes, I have to share it again. Okay. This is it, yeah. And now you can find some, as I said, Earth observation dedicated libraries like Dask, like Ecolis, like Geodac, also Boto in order to connect with your S3. So this is provided already within the within this images. These packages of observation packages are not installed within base environment. Yeah, you can see much more libraries which are installed within DDL Conda environment. Okay, this was from my side. Now, Michael, you can go on with your part. And quick reminder, we have 10 minutes.
Yes,
we
okay.
have 10 minutes to the end. Okay.
Okay,
So
thank you,
the floor is
Patrick.
yours again.
Okay. Please tell me if you see my screen.
Yeah, the screen and the terminal.
Okay, so the screen and the terminal is okay. Sorry. The issue I was facing was with simple command scp, but I completed this from second terminal. Now I can see the because I from local machine sent the support team open rc file here to the virtual machine. It will be necessary for future steps. Let's first install Python 3 OpenStack client. It is necessary to perform operations with OpenStack commands. And I will make sure in a moment that I have already installed S3FS. It should be, but I will make sure. Okay. Okay. Now we have Nano text editor already installed. Let's authenticate by source command to the project. Using this file is which I before downloaded from the project, from the Horizon OpenStack RC file. And of course, I need to pass the password. And let's check simply command. Is this working? Yes, seems to be working now. Okay. Now, before I mount my object storage, which we created before in Horizon, I need to obtain the EC2 credentials. I need to create this credentials. So the OpenStack command is credentials create. Okay, let's it will be much easier for me. And we have now access and secret case. And let's save and store this access and secret in a password file. So I will perform the following command. First, we need to paste access, and second one will be secret. Oh, sorry, of course, mistake. Secret access and secret. Now it's okay. And store it to this password. This password. Free pass. Okay. We need to change by change mode command. It should be 600. Okay. Yes, we need to uncomment this one to allow users access to the mounted point. In short, it's not all still. Okay, we have installed S3FS. Let's create, but here in your user direction, mount point. Let's name it. Sorry, I need to check if it will be not. Okay. Okay, so let's name it simply mount. Okay. Now the command to the which will allow us to mount this this folder, and maybe not the folder, but this bucket to this place where the folder is called mount. I need to Let me copy paste the whole comment, because it is a little longer than one comment. Let's make sure we have all paths correct. Yes, and this is mount. This is our new. And of course, we need to make sure where object storage container webinar bucket is named. And I believe it is webinar bucket. Sorry, webinar bucket. Webinar bucket. Okay. Let's test. Sorry, my connection is now freezing with this terminal, unfortunately, but maybe it will be unlocked for a moment. But in the meantime, I will try to connect from new terminal. Yes, okay, we have connection. And we can see now, because we mounted the object store, the container bucket to our virtual machine, we can see the file testowy. We should be able to remove or create new files here.
Michał, unfortunately, I have to stop here. We can see that it's working here because we have file within the S3, but unfortunately we're running out of time, so I have to. Yeah, it works. I have to go to the end with the webinar. So. Give me a second. I will also tell the screen. Now you can also see the second file, which was just created by Michał. Okay, I will share my presentation. Okay, and slides. Okay, so in fact, this is the this was the last webinar within this three of them. Yeah, as I mentioned to you during the last sessions, I really encourage you to visit our GitHub page, where you can find a lot of tutorials, a lot of resources, how to use the HDA, how to use Hook Stack, not ISLET, but you can see. You can find a lot of materials within Destination of Data Lake documentation, which are strictly dedicated to ISLET as well. But I encourage you to visit this GitHub if you want to, let's say, start your journey with with Destination of Data Lake, with HDA and other services. So that's all from my side. Thank you very much, Michał, for this. For this introduction of possibilities of ISLET, which, as you can see, it's not only about virtual machines, it's about networks, about storage, about creating your own buckets. So a lot of possibilities. We have like 2 minutes left, so maybe you have any questions. I can't see any questions. So if you have any question, if any questions are raised, you can catch me on LinkedIn. You can write me on my email. I'm pretty sure that I can help you with anything which is dedicated to the destination of data lake. If not, I will pass you to the right people. So that was all from my side, and thank you very much for this free webinars, and thank you, Michał, one more time for introducing ISLET.